Hello, friends. I'm glad to share with you the hardcover edition of Digital Dharma, how AI can elevate spiritual intelligence and personal well being. One of the things you learn here is the art of the prompt. So, by using the correct prompts and getting knowledge and information from different sources, you can create new contexts, new meanings, and understand new relationships and actually have access to ideas that have been expressed before, but when you connect them with each other, a new understanding emerges. Let me give you an example. Today, I decided to explore the idea that the quantum field is a consciousness field. And that's who we are. We are the field and the knower of the field, as has been expressed in the Upanishads, chapter 13 of the Bhagavad Gita. I am the field and I am the knower of the field. So I use the following prompt today. According to quantum field theories, particles are excitations of the field in the same way as the vibrations of a violin or a guitar are excitations of a single string. In other words, particles have no intrinsic reality, shape, size, or form. Shape, size, and form are abstractions of the field. That was my prompt, pretty complicated, but here's the answer. Quantum field theory, QFT, is a fundamental framework in theoretical physics that describes how particles interact and behave. It combines classical field theory, special relativity, and quantum mechanics, providing a comprehensive understanding of the universe at the smallest scales. Particles as excitations of fields. In quantum field theory, the concept of particles is fundamentally different from classical physics. Here are some key points to understand this perspective. Fields as the fundamental entities. In quantum field theories, fields are the primary entities. Each type of particle corresponds to a specific field that permeates all of space. For example, the electromagnetic field corresponds to photons, while the electron field corresponds to electrons. Excitations of fields. Particles are viewed as excitations or disturbances in these fields. Just as a violin string vibrates to produce sound, fields can have excitations that manifest as particles. These excitations can be quantized, leading to the concept of particles having discrete properties such as energy and momentum. Absence of intrinsic reality. Unlike classical particles, which can be thought of as having definite shapes, size, and forms, particles in QFT do not possess intrinsic characteristics independent of the field. Their properties emerge from the interactions and excitations within the fields, making them more abstract than tangible objects. The ideas of shape, size, and form in the context of QFT can be understood as follows. Emergent properties. The characteristics we associate with particles such as mass and charge are emergent properties that arise from the underlying field dynamics. For instance, the mass of a particle is related to how it interacts with the Higgs field. Quantum fluctuations. The fields are subject to quantum fluctuations, which means that the properties of particles can change depending on the energy and conditions of the field. This leads to phenomena such as virtual particles, which exist temporarily due to these fluctuations. In summary, quantum field theory revolutionizes our understanding of particles by emphasizing that they are not standalone entities, but rather excitations of underlying fields. This perspective challenges our classical intuitions about reality, suggesting that the fundamental nature of the universe is more abstract and interconnected than previously thought. By embracing this view, we can gain deeper insights into the workings of the cosmos, and the fundamental forces that govern it. So then I said, what are the implications of particles having no intrinsic reality? And the answer was very lengthy. Reality is fundamentally indeterminate at the quantum level. Particles do not have different properties like position or momentum until they are measured or observed. Their properties exist in a state of superposition of possibilities until observation causes the wave function to collapse. The act of measurement or observation plays a crucial role in determining reality. The observer effect suggests that the very act of observing a quantum system influences its behavior and properties. Locality and realism, cornerstones of classical physics, break down at the quantum scale. Experiments have shown that the universe is not locally real. Particles can influence each other instantaneously across vast distances, non-locality, and do not have definite properties before measurement, which is lack of realism. Quantum entities like particles should be thought of as excitations or disturbances in underlying quantum fields rather than discrete objects with inherent properties. Their characteristics emerge from interactions within these fields. The fundamental nature of reality may be more abstract and interconnected than previously thought. Quantum physics challenges our classical intuitions about distinct objects existing independently in space and time. It raises a question about determinism, etc., etc. But then I ask the following question. Since all our knowledge of the quantum field occurs in consciousness, and in the deeper reality, there's no subject-object split, could we posit that quantum field is a consciousness field? So it says the quantum mind or quantum consciousness hypothesis suggests that consciousness cannot be fully explained by classical mechanics or neural interactions. Instead, they propose that quantum mechanical phenomena such as entanglement, superposition play a significant role in consciousness. Well, we know all this, but then it suggests other speculations. But in the end, it actually has no specific answer. But I'm asking you, how do you know there's a quantum field? Well, because of all these theories. Where are these theories conceived? Because there's consciousness. Where are these hypotheses experimented with other than in consciousness? And where is actually the appearance of these particles happening? And one of the answers I got was very nice. One approach suggests that memory traces are created by writing sequences of information states into the 0 point field, ZPF, a universal background field. Conscious memory retrieval involves reading these information states from the ZPF, 0 point energy field. Quantum probability theory and memory construction. Quantum probability theory is applied to cognition to explain how memories change over time. It posits that recalling a memory can alter how it is perceived, similar to how measurement in quantum mechanics affects the outcome. But now, forget all this, okay? Look at me. And if you recognize me as Deepak Chopra, then you're reconstructing that image from a memory. And that memory is, according to one of these theories, in the quantum field. So obviously, the quantum field is an energy field, but it is also an information field. And energy and information are mental constructs for memory. All we experience is memory. You recognize me because you have a memory of an abstraction that appeared as this image and this voice and this nose and this shape. And then we all agreed to call it Deepak Chopra. But in fact, there is only the field and the knower of the field, and you are that. Tattvamasi. I am that. That alone is, and that is the field and the knower of the field. Now, of course, when I come up with all these ideas in the past on my own, and now with the help of prompts and AI and other ways to look up information and knowledge, most scientists still roll up their eyes because it's unnerving to them that everything that appears tangible is actually intangible. It is immortal, timeless, spaceless, fundamental, irreducible, infinite, and divine. And you are that.